Question 4 for the 2014 Level 2 electricity. A proton moving at right angles across magnetic field, strength 0.65 Teslas. That's our B. And the constant speed of the proton is V, 4.8 times 10 to the 3 meters per second. That's 4.8 kilometers per second, if you want to put it that way. Pretty fast. Calculate the size of the magnetic force on the proton while it's in the field. F equals BQV. Plug your numbers in, and that'll give you the value. Newtons are the units. Two significant figures by the look of it, because everything else is in two significant figures, and you're multiplying and dividing. Piece of conducting rod, whose ends are connected by a wire as shown, is moved through a magnetic field directed into the page. Direction the rod is moved is shown by the arrow, and we've got the arrow right there, to the right. On the diagram, draw an arrow to show the direction of the induced current around the loop formed by a rod and a wire. Okay, so this is conventional current, as they've stated there. That's a flow of positive charge. If we consider a positive charge moving to the right and use our right-hand slap rule, we can work out the direction of that positive charge, and then that'll be the direction around the loop. So with a right-hand slap rule, our thumb is the direction of the movement of that positive charge, the movement of the conventional current. Fingers into the page, showing the direction of the magnetic field, the X into the page, and the slap is therefore going to be upwards. So there'll be a force on this upwards, therefore a current flowing around in that direction of the loop. Okay, so once more really quickly, right-hand slap rule, thumb in the direction of the conventional current. A single positive charge moving is equivalent to conventional current to the right. If it was an electron going the other way, it would still be the same. If it was an electron going to the right, negative charge, conventional current would be to the left. But in any case, this is positive charge to the right. That's your thumb, fingers into the page, slap upwards, or into the screen in this case, I suppose. C, explain why there will be an induced current in the rod and wire due to movement of the rod across the magnetic field. Never quite sure how much detail to give into this, but it's because with the fixed magnetic field, that interacts with the magnetic field of the electrons in the wire as it moves through. Yeah, that's probably going too far. Perhaps you can use the right-hand slap rule to go from and explain how you arrived at your answer using the right-hand slap rule. The other way, as I started to say, is you talk about the electrons are being pushed and the positive charges in the wire are being pushed to the right. So electrons have a magnetic field around them as they move, and that magnetic field, and I've seen some cool diagrams that go into that, but that magnetic field, did I do that the right way? I think it might be the other way. Yeah, the electron will be that way. The magnetic field around the positive charge will be in the other way. But in any case, as that electron or that positive charge moves through the field, its magnetic field interacts with the bigger magnetic field of the permanent field, and that causes a force one way or the other. The positive charge is actually going up and the electron's going down in this case. And that's shown by the right-hand slap rule. If you search for some cool animations on YouTube, you'll be able to see that how a magnetic field seems to open up in space as the moving charge passes through space. Anyway, carrying on. D, in the situation above, the length of the rod is 0.40 meters. L, magnetic field strength. B, the rod is moved with a speed V of 4.6 meters per second. The combined resistance of the rod and wire is that. Calculating the voltage induced, V equals something. Calculate the size of the force. That must be, so F equals something. That must be applied to the rod to keep it moving at a steady speed through the magnetic field. So, do we have any other information? V equals I times R would be good. Do we have a current induced earlier on? No. Oh, hang on, the constant speed of the proton. No, we've already used that. Carrying on. Rod and wire, calculating the voltage induced. We must have to use V equals VBL. B VL. So this is, I just wondered if we were doing another calculation, but, and then F equals, I don't know, 4.6 meters per second. something a little bit odd about that. Hang on, hold on, I'm going to pause and think. Okay, I was heading in the right direction. I was just trying to get my brain in gear. So once we've got V equals BVL, we can work out the current passing through it that's being induced because of the induced voltage, I equals V over R. So we just take that value of V, put it into there, we take the value of R given to us there, and then now we can use F equals Bill. L is again the same length, I is the I that we calculated from earlier, and B is the same magnetic field strength. And that'll give us a value for the force in newtons, 2SF. By the look of it, again, everything's in two significant figures. And I think that's the end of it, actually. Yep, thank you very much. Hope you found all this really helpful and all your exams go well.